All right, so we'll be looking at the concept of teaching and the characteristics of good science teaching. We're going to be looking at the nature of science, its implications for teaching, the objectives of science and integrated science teaching. And then finally, we'll be looking at the current trends in integrated science teaching. I think that's the part that I like the most. So once again, this is spatial methods in integrated science, and we'll be looking at the concept of teaching and the characteristics of good science teaching, the nature of science and its implications for teaching, the objectives of science and integrated science teaching, and the one I love most, current trends in integrated science teaching. So say we are teaching. What exactly is teaching? What is teaching? If someone says teaching is going on in that place, what exactly does it mean? Course rep, answer us since your microphone is still on. What is teaching?
Okay, it means what I understand by teaching is a kind of transferring knowledge, like what a teacher have, like transferring it to the students, something like that.
Yes. So what do you mean by what you have? So if your father gives you money
The
because
knowledge.
that is what he has, is that teaching?
No, the knowledge the person have about something.
Okay, what the person knows about something. That is correct. That is correct. Who else is in this call? Ifunanya, what do you understand by teaching? Unmute your microphone and respond. Purity, Ifunanya, what do you understand by teaching? What is teaching? The other Ifunanya, okay, Purity.
Yes. Teaching, to my own understanding, it means transferring knowledge.
Yes. Okay. All right. Thank you. Mute your mic again, please. So you are both correct. Teaching means transferring knowledge, but it has to be intentional. You must mean to transfer knowledge. So it is not about just transferring knowledge. This is not. It doesn't occur by Bluetooth. You have to be intentional. So if someone wants to teach you, please mute your microphone. I shouldn't be saying this. I don't want to mute everybody. Who is IJGWU? Mute your microphone, please. I shouldn't be saying this. You're too old for that. Come on. All right. So teaching has to be intentional. You must intend to actually transfer knowledge. If someone wants to teach you how to count your numbers 1 to 10, the person has to be intentional. The person actually has to want to teach you that thing. That is where the intentional aspect comes in. So teaching is the intentional and systematic acts of helping others acquire knowledge and skills. It is a systematic act of helping others acquire knowledge and skills to enhance their understanding of something. That's just to enhance understanding. So it's intentional, it is systematic. But you have to, go from one step to the other. You don't just want to teach somebody class 1 to 10 and start with 10. So no, you have to start from the simplest to the complex, simple to complex, not just waking up and being to, number 20. No, that's not. So it has to be intentional, it has to be systematic, and you are transferring knowledge. You can also transfer skills to enhance someone's understanding of something, either a subject, either a particular action, whatever it is, to help the person, promote personal and intellectual growth. And we all know that teaching occurs in various settings. It's not just in the classroom. Teaching can happen in different settings. So we know we have the formal classroom settings, just like, your classrooms or the ITS lab in the university, that's in the campus. That is formal classroom setting. We have online platforms, just like what we are doing now. We are using video conferencing to teach. We also have one-on-one tutoring. One-on-one tutoring can happen anywhere. It can be formal. It can happen online. It can happen, even in the market, informal setting. So we have formal classroom settings. We have the online platform. We have the one-on-one tutoring, and then the informal learning environment. Someone should give me an example of informal learning environment. Jennifer, give me an example of an informal learning environment. Jennifer. Are you looking for your microphone? Or you are not even in the class? Jennifer, you are not here. Okay. Blessing, give me an example of an informal learning environment. Okay. Blessing is not here too. Okay.
I'm here, ma. Lecture hall.
That is not informal. You're not listening. I said informal. Let's not join the call with two different gadgets because I'm taking notes of people that are not in this classroom. So I need to know, are you Blessing? Are you here with two different gadgets? Is Blessing still here? No.
Yes, ma'am. Yeah.
Okay, so give me your, can you respond now? Informal. Informal.
An online class.
That is wrong. That is wrong. Daniel.
I think an informal class, an example should be a household setting between maybe a mother and a child.
That is correct. That is informal. That is informal. Informal setting. You did not even plan it. Even if you planned it, it is not happening under this strict formal setting. You cannot say your classroom on the campus is informal. It's not informal. It's formal because you are sitting and the teacher is there with you, whether it is a lecturer or your classmate. As long as you're sitting and it is in that setting, it is formal. We are online. We are in actually a formal teaching class right now, whether it is virtual, just like we are, or not. Informal means you are in just anywhere. So it could be your house, you are speaking with your daughter or your sister or your brother, and you're saying A plus B is equal to this. That is informal setting. Nobody is paying you to do that. So one of the characteristics of a formal teaching setting, someone has to get paid. Someone has to write an exam. Someone has to get a result. Someone has to pass or fail. That is formal. Informal means you're not failing. You're not passing. Nobody is paying you. Nobody is flogging. Well, they can flog you anyway. You can flog your child. But at that moment, It is informal because nobody employed you to do that. That is what we mean by informal. So let's assume, I know you have seen a carpenter's shop and there are apprentices. Would you call that a formal setting or informal setting? Mercy. A carpenter's shop, someone undergoing apprenticeship. Is that informal or formal?
I would say that is formal.
Yes, that is formal. That is formal. Why is it formal?
I mean, that is their own classroom. And that is their own classroom, and learning is going on there.
Yes, and there is somebody that is the Oga Pata Pata right there, and someone that has to learn, and someone that has to either pass or fail before they will, allow you to go. So these are some of the formal and informal settings that we know, and they are always around us if you pay attention. I'm trying to share my screen again. Do let me know if it has come up. Can you see my screen? Yeah. Is it coming up?
Not yet.
Daniel,
not yet
is my screen coming up?
It's not yet
Okay.
up.
Okay. Okay, it's fine. So now there are characteristics of effective teaching. And I came up with an acronym TEACH, T-E-A-C-H. Characteristics of effective teaching. What is it about teaching? What is it that will be happening? And you will know that teaching is actually taking place. Effective teaching. Effective teaching. Effective teaching in this case means that you are actually transferring either knowledge or skill. So I came up with these 5 characteristics. T-E-A-C-H. Teach. Now, T here stands for transparency. T stands for transparency. So the person that is teaching has to be clear in communication. The person teaching has to be clear in communication, has to be transparent. What you are saying should be what the students are hearing. You don't need to use ambiguous words. You don't need to use final year students' language to teach JSS1 students. You don't need to use the language that you will use to talk to a 15-year-old, to talk to your 2-year-old. No. So your language in teaching must be transparent. So it must be clear. Communication must be clear. That is T, transparency. The second one is E, for engaging. E, for engaging. For effective teaching to happen, you must make the learning interesting and involve the students actively. For learning to occur, effective teaching to happen, learning must be interesting and students must be involved actively. That is E, for engaging. A is adaptability. A, adaptability. Teaching methods must be adjusted to suit diverse learners. Teaching methods, your strategies, the way you teach must be adjusted. It must be adaptable to suit diverse learners. If you go into a classroom, whether junior secondary or tertiary or kindergarten, there are different types of learners there. So when you get into the classroom, you must, in fact, you must master the skill of adjusting your teaching strategy. You can get into a classroom and in your mind, you've already planned that what people are going to do that day is maybe group work, for example. But there are people that don't do well in group activities. In fact, if I share your class into groups now, there are some groups that only 1 or 2 persons will be active. So when you find out that such a thing is, it is possible that this kind of thing can happen, it is your duty as a teacher, an effective teacher, to adjust. So instead of saying, we are going to do group work today, and then you are so rigid in it, you have to be flexible. And you can even ask them to choose between group work and some other thing or some other strategies, or you adjust them as you go. Use group work, use demonstration, use role playing, all in the same class for effective teaching to happen. So we're talking about the characteristics of effective teaching, and I came up with this acronym TEACH, T-E-A-C-H. Now, the first T, the T there is transparency. Your language must be clear. It must be transparent, not too big for your learners and not too small for your learners. The second acronym is, the second letter there is E, for engaging. For effective teaching to happen, learning must be interesting and students must be involved actively. The next letter is A, adaptability. You must, as a teacher, be able to adapt your teaching strategies, adapt your methods of teaching, adjust them to suit different learners. People that learn by doing, people that learn by hearing you, people that learn by, you have to be able to adjust. The next letter is C. C means clarity. That is another form of clear. Clarity. You must clearly tell them expectations. They should know your lesson objectives. Remember that when I started this lesson, I mentioned the 4 things that we'll be looking at. So I have clearly conveyed the lesson objectives to you. So now you are waiting and expecting those objectives to be met. That is clarity. And it helps effective teaching. And then the last letter there is humanity. So you must show empathy. You must try as much as you can to build positive relationships with your students and your children. Characteristics of effective teaching: teach. T for transparency, E engaging, A adaptability, C clarity, and H humanity. Now, these characteristics actually, cuts across every form of teaching. Whether you are teaching science, whether you are teaching arts, whether you are teaching music, whether you are teaching sculpting, that acronym is like an umbrella term for the characteristics of effective teaching. I also went further to, break them down and to tell you that for this type of, for science teaching to be good, I listed 10, features. All these features are actually coming from the first, those first acronyms that I gave you, the TEACH. For good teaching to happen, it must impart, oh, thank you, Daniel. It must impart knowledge. The material that you are teaching must be interesting. Students must be engaged at their level of understanding. Okay, let's put it this way. The first one on the screen is it must impart knowledge and guide the learners through the teaching and learning process. Which acronym does this fall under? Which acronym does this fall under? Collins. Collins. Yeah. So I said it must impart knowledge and guide the learners. Which acronym does this fall under? Collins, are you there? Are you trying to speak? We cannot hear you. Okay, Miracle. Miracle. Okay, so Collins is not here. And Miracle is not here. Chukwudi.
I think it's engaging.
Speak up, please.
It is engaging.
I'm sorry, what did he or she say? Did anybody hear him or her?
He said engaging.
Okay, for some reason I can't hear you.
Engaging.
Does anyone want to respond to the question? Oh, was it engaging that you were saying?
Yes, ma'am.
Okay. What is your name? I'm seeing Chukwudi on the screen. What's your name?
Chukwudi Lovett, ma'am.
Chukwudi Lovett.
Yes.
So
ma'am.
when you attend, that's good to know. When you attend virtual sessions, make sure that your device is saved with your full name.
Okay, ma'am.
Whichever virtual session, whether it is a teaching session like this or an interview or whatever it is, make sure your device is saved with your full names. It helps them to to take notes. Okay.
Okay.
All right.
Okay, ma'am.
So the second one, we said the material. Yeah, you're welcome. The material that you are teaching must be stimulating. It must be interesting. I think it also falls under engaging. Students must be engaged at their level of understanding. Which one is this one? Cynthia. Students must be engaged at their level of understanding. Which acronym does this, which letter does this fall under? Cynthia. Okay, Cynthia is not here. Who is Ejim? Ejim. Ejim is not here. All right, so Cynthia is not here and Ejim is not here. Owo. Owo. Okay, Owo is still also not here. Nice.
Ma, it's under.
Oh, okay.
I'm talking, ma.
Okay, I can hear you now. So which letter does this fall under? Students must be engaged at their level of understanding. Which? Adaptability. Are you sure?
Yes, ma.
Are you sure? Mercy, are you here? What do you have to say about that? Mercy is not here. Cost rep, is she correct? Students must be engaged at their level of understanding. Is that adaptability? Cost rep has disappeared. Okay. Does anyone want to say anything? You know, you can raise your hands, right? Okay. All right. So I don't think it is adaptability. I think it is clarity. It should be clear. Let's look at it again. Not clarity, sorry. Transparency, the T. So it has to be clear and transparent in communication. That means you should be able to talk to them in the language that they understand. Now, adaptability means adjusting your teaching methods to suit, everybody in that particular class. So while you might actually say it is true, engaging them at their level of understanding, I think it is more about, being clear in communication. So you know that you can actually change your teaching method when you get into the classroom. Instead of 2, you are using 1 or 5, and yet you are not engaging them at their level of understanding. I can come into your class as 200 level students, and I start talking to you like you are. I start using different, teaching strategies, but I'm still speaking PhD grammar. I don't think I'm engaging you at your level of understanding. Or I go into a kindergarten class, and instead of saying A is for apple, I am I am telling them about characteristics of good science teaching. And then I am dancing, I'm playing drums, I'm doing drama, I'm asking them to talk. These are different teaching strategies. So I am adapting. But at the end of the day, I am not communicating. Do you understand this? Oh, did you understand that? Hello?
Yes, ma. Thank you.
Did you understand that? Okay. All right. So
Yes,
let's quickly rush through it. It's okay. So engage them at their level of understanding. Teaching material must be explained clearly. Teaching process must be hands-on, that they must do something and their minds must be on too. So when we say hands-on, minds on, hands-on means your hands must be doing something. Minds on, your mind must be, engaged too. You should be thinking of something. You should provide teaching materials if they are available, or you can improvise, and and so on and so forth. Valid assessment methods, give quality feedback. These are all under the same TEACH. Let's look at the objectives of science. Does anyone have any question? If you have a question, just raise your hand. I will raise your virtual hand. I will call on you. Let me check. Nobody yet. Okay, let's look at the objectives of science. I think you did this thing in 100 level. Objectives of science. I have 8 of them here. Why do we teach science? That's what we mean by objectives. Why do we teach science? To encourage and enable students to develop curiosity, make them want to think, to ask questions, to not take everything the way it comes. That is one of the reasons why we teach science. Encourage and enable students to develop curiosity about science, about nature, about everything. Number 2, to acquire the knowledge, conceptual understanding, and skills. We teach science so that you can have the skills, the knowledge, the understanding to solve problems and make informed decisions in scientific contests. For example, instead of just accepting the fact that the reason why one woman on your street doesn't have kids is because she somehow has eaten up all the babies in her womb. As a scientist, we are trying to give you the knowledge, the understanding, and the skills to make informed decisions. So now that you have been exposed to science, you have been exposed to various subsets of science, biology, chemistry, physics, agriculture, and all, you should be able to make decisions with facts. So you don't easily swallow everything that they are saying. When people come to you and say things, you look at them and you're like, I don't think so. Are you sure that? What if? How about? This is what makes you a scientist, a science student, a science educator. And this is one of the reasons why we teach science, for you to have the skills, the knowledge, the understanding to solve problems and make decisions with facts, especially when it concerns scientific matters. Another reason why we teach science is for you to develop skills. Skills that will help you to carry out scientific investigations and evaluate scientific evidence to draw conclusions. It's just like people that are football coaches. Football coaches, those guys are scientists because they sit down and they map out strategies. If you see their notes, If you see their drawing boards, it's going to marvel you. So this is like you now have the skill to design and carry out scientific investigations. In the next 2 years or so, or next year, you will be assigned to project supervisors. Because we believe that we have equipped you with the skill for you to design and carry out a scientific investigation, and then to draw conclusions from evidence that you are seeing. That is one of the reasons that we teach science. We are teaching science for people to be able to communicate scientific ideas, arguments, in a variety of ways. When you sit with people who are talking about carbohydrates, you should know what carbohydrates are. You should be able to communicate that idea. If you get into somebody's house and there is smoke, you should be able to communicate to them why carbon monoxide is toxic. That is one of the reasons we teach science. You should be able to communicate scientific ideas, make scientific arguments, and give, experiences in a variety of ways. Anywhere you are, you will have something tangible, something reasonable to contribute. Another reason why we teach science, so that we can all appreciate the benefits of science and appreciate the limitations of science and its applications to technology. For example, we are in this beautiful era of artificial intelligence. We are able to appreciate the benefits of artificial intelligence, the benefits of using technology, the benefits of using all these gadgets, phones, laptops, and all that. But we are also able to understand that there are limitations of science. There are things that science cannot do. There are things that science can do that are not morally okay with you. There are tools that are awesome to use. And there are also tools, there are still tools that could annihilate an entire country. So science is taught for you to appreciate the benefits of science, appreciate the limitations, and know the applications of science to technology. Science helps you to think critically to solve real life problems. I don't know if you've ever been in a position where you will say something and somebody is like, you're talking like a scientist, or this one is behaving like a scientist. In fact, anytime you're in a situation where people are gossiping, saying something about somebody, and then you're like, are you sure? This thing you're saying, do you have the evidence? You're a scientist though. You're a scientist because now you're thinking critically. You're subjecting everything to test. It is no longer garbage in, garbage out. And you will find out that when you do it once or twice to people, asking them whether they are sure about something, asking them for evidence, asking them, can I mention this thing you said to this person? They will stop gossiping to you. When they are talking and you pass, they will keep quiet because they know that that thing they are saying has no basis, has no foundation. It is gossip, and it is possible it is a lie. Okay, now we also teach science so that we can understand the nature of science. We can understand that science, technology, and society work together. Science, technology, and society work together. There can be no science without technology because science gives birth to tech. And there can be no science and technology without society because it is society that will use what science has brought out. So science, technology, and society work hand in hand. So when we teach science, we try to make you understand the nature of science and the interdependence, the interconnectedness between science, technology, and society. And lastly, we teach science so that we can demonstrate the scientific attitudes Do you remember the scientific attitudes? I'm sure you did it in 101. Scientific attitudes. Somebody should mention 1 or 2 or 10.
Curiosity.
Igbokwe. Oh, okay. Yeah. Who said that?
IJGU Messi.
So you don't even know your name. IJGW. That's what your phone is showing us. What is your real name?
Ugu Messi.
Okay, Ugu Messi. So why is it saying showing IJGW? Okay. Curiosity, open-mindedness, so many scientific attitudes. Now that we have seen,
Yes,
you said? Someone said something. Okay, now that we have listed the objectives of science, that is the reasons why we teach science, I want us to look at the aims and objectives of integrated science. I'm just going to talk about the overall aim. Why do we teach integrated science? You see, we have gone from teaching as a whole down to science teaching, and now we are coming home to the one will concern us. The aims and objectives of integrated science. Why do we have integrated science in our curriculum? Why do we have integrated science in our curriculum? Okay. Someone should give us his or her own, version. If you think you know the reason why we should have integrated science in our curriculum, let us know.
I think we have.
Okay. Is that Daniel?
Yes, ma'am.
Is it?
I think we have.
Okay, so what did you say?
Yes, ma'am. I think we have integrated science in our curriculum because it opens learner up to basic scientific content. Since we are combining the major branches of science, it opens them to the different scientific content at the basic level, giving them basic understanding and how to apply it in solving problems.
That is awesome. Thank you. Oku Anthony, I can see your hand. Go ahead.
Okay, it makes things easier for the community. Make them build the equipment for what they're meant to use.
Daniel, Anthony, I didn't hear you clearly. Please speak up. Anthony.
It makes things easier for the community.
Anthony has disappeared. Okay. I still didn't get that. Okay, could you please put it in the chat? Put it in the chat box. Let's read it.
For community.
For continuity, is that what you said?
Okay.
Okay, just help us and put it in the chat. I think the network is either disturbing me or disturbing your gadget. So just type it out, we'll read it on the screen. But if you said for continuity, that is cool. So why do we have integrated science curriculum? The major overall aim of the integrated science curriculum is to provide learning experiences that will enable students to develop scientific literacy. Learning experiences. The overall aim of the integrated science curriculum is to provide learning experiences that will enable you and I to develop scientific literacy. What is scientific literacy? Knowing science. knowledge about science. This is why we teach integrated science in primary, in nursery, in primary, in junior secondary, and even senior secondary as different subjects. In nursery, they do science. They may not call it integrated science or primary science or general science, but they do science in nursery. When you go to your child's class or your brother's class and you see them in the compound looking for living and non-living things, they are doing science. In primary school, we have basic science. We already know what they do there because we have the curriculum. They teach them, some form of computer, some parts of physical and health education, the other parts from basic science, which has chemistry, which has physics, which has, they even do introductory technology. So all these things are done in the primary school in very simple ways. And then in the secondary, junior secondary, you have basic science and technology. Now that is where you have ICT, you have physical and health education, you have, I think, introductory technology, and then you have basic science. These 4 subjects are now housed inside basic science and technology. Why do we teach this course, this subject? Why? Why is it necessary to have science at all levels? We want everybody to be scientifically literate, to know science, to know that when there is eclipse of the sun, it does not mean that werewolves are coming. When there is when there is too much cold, it doesn't mean that, or when there is flooding, it means that we have used rubbish to fill up our drainage system. It is not the river goddess that is angry with us. This is one of the reasons why we teach integrated science from that tiny age. Let them know that there are some things that they are doing that are scientific in nature, and not really all about superstitions and myths. So the overall aim of the integrated science curriculum is to provide learning experiences that will enable students to develop scientific literacy so that everyone can participate actively in this our changing society and prepare for further studies or careers in fields where the knowledge of science is useful. Just imagine that we do not have basic science, and all of a sudden, you are told to do chemistry, you are told to do physics, you are told to do biology, and you have never even heard about atom. You have never heard about chemicals, because we teach chemicals in basic science. We teach atom, we teach genetics in basic science. From primary school, they do genetics, they do family traits. In junior secondary, they repeat these things in a higher form. Imagine you didn't even know anything about these things, and you get to SS1, you're seeing chemistry, physics. You're like, what is happening here? You will find out that we will start having a decline in the number of persons that are even doing anything in science. We may end up not having doctors or nurses or engineers or software developers. We may not even have these things. Why? Because when the child suddenly sees something that is so alien, the person will quickly enter the other parts that he or she is used to. That is it. So the overall aim of integrated science is for you and I to be scientifically literate, preparing our students to adapt, to participate in a rapidly changing society. The society is changing so rapidly that, in fact, as at this time, 3 years ago, I am not sure that anybody knew what Microsoft Copilot was. In fact, I'm not sure it existed. As at 4 years ago, I am not sure Gemini existed. So society is changing rapidly. And if you are not scientifically literate, if you do not have the scientific attitudes, especially of curiosity, open-mindedness, you will be left behind. So this is why we teach integrated science. There are broad aims, but I'd just like to talk about the overall aim of teaching integrated science. You know, because of that reason, based off of that, you know, those objectives, in integrated science, you are made to observe. These are now the scientific skills, the science process skills. You are taught how to observe carefully. You are taught how to report accurately. You know how to organize information. You can now generalize based on acquired information. What do we mean by that? If you get into, let's say you come into Nigeria and you go to state number 1, and let's say it was June, between 1st of June to 10th of June, you were in Abia State. It rained heavily for 5 days straight. Next year, you come into Nigeria, you are in Enugu State, around the 2nd of June to 8th of June. It rained heavily for 5 days. The next year, you entered Nigeria and you are in Akwa Ibom State. Around that same June, it rained heavily again for 5 days. You can go out and tell somebody that from 1st June to 10th June in Nigeria, rain is falling. You can actually generalize based on that acquired information. You can go out and tell somebody that, do you know that if you go into Nigeria and you go to Akwa Ibom, Enugu, Abia, Imo, between 1st of June to this, it will rain for 5 days, and it might be possible that it will happen because it has happened to you over and over again. That is what we mean by generalizing based on acquired information. In fact, it can even happen in your own classroom. You come into 300 level and they tell you that, do you know this course? Last year, 5 people failed. 2 years ago, 5 people failed. 3 years ago, 5 people failed. Till 10 years ago, 5 people still failed. Believe me, you can be very sure that 5 people will still fail in that yourself. I'm not saying anybody is going to fail. I'm just saying that you can actually generalize, you know, based on acquired information that, you know, you have gathered over and over, you know, over time. You can predict. That's what I just did, saying that this thing happened and happened this time, the other time. You can now predict that it will happen again. You can design experiments. You can explain phenomena using models. So this is what science teaching does for you and I, whether as students or as educators. First off, we talked about teaching. We said it is an intentional act and it is systematic. Intentional because you must, you know, you must decide that, oh, I want to teach this person how to, you know, play penalties. I want to teach this person how to play free kicks. That is an intention. And it is systematic. Systematic now in the sense that you must go through a process from stage 1 to stage 2 to stage 3 to a final stage. And then you say, oh, you have done well. You can now play free kicks. You are now the GOAT, the greatest of all time. You are now small GOAT and big GOAT. I'm not saying anything, not calling anybody's name. Okay, so for teaching to happen, teaching has to have some characteristics. Remember that we said that teaching occurs in various settings. It can be formal. Formal means exam is involved. Somebody must pass or fail. Somebody is being paid to do that teaching. It is a formal classroom. It can be online classroom. It can be one-on-one, and it can still be informal. Now, online classroom can also be formal, just the way we are right now. It can also be formal. It can be informal in the sense that, for example, they teach something in your classroom and then you tell your course rep, I don't understand this, so please, I'll call you by 9 p.m. or you will help me and explain it to me. You will call the person on WhatsApp and your course rep is explaining it to you. It is informal, but it is online. I hope you understand what I am saying. Let me give reactions if you are still following me, please. I want to see your reactions, emojis. Okay, thank you, Jennifer, Obiora, Collins, Anthony, thank you. Thank you, Daniel, all right. So, thank you, Judith. So that's what we're talking about. Now, one-on-one tutoring. One-on-one can still be formal and informal. One-on-one can still be formal and informal. One-on-one can be formal if you are doing home lesson for somebody. It is formal. They are paying you for that. It is a job. So it is formal. It can still be informal when you go to SU, maybe it's SUB that they call it. You go to SUB. Is it SUB? Shires something. You go to SUB and then you run into Loveth Chokode. And you're like, hey, come. That thing that they said yesterday, what is the acronym again? That TEACH. That C is what? That at that moment, it is one-on-one, but it is informal. They're not paying anybody for that. So I need you to understand the differences between formal and informal, so that when they ask you, teaching via Google Meet, is it formal or informal? You should be able to say it is both, and then give serious examples, give reasons why it can be formal and informal. That is what makes you a scientist. I gave you characteristics of effective teaching. So I said TEACH. T is transparency. What you are saying must be clear. It must be loud. Let them hear you. Speak the English that they will understand. It must be engaging. You should make that learning interesting. You should involve students actively. I am teaching you virtually, but I have involved you. In fact, that is one of the reasons why some of your classmates are not here. They will just join the class and go away because they are like, online classes, I beg you. It's not with me. So it can be, adaptability. You have to adjust teaching methods to suit diverse learners, just different people, different learners. You come into your class, JSS 3 students, average age 12. Okay, let's say 13, average age 13. You come into that class, and instead of you to teach them basic science, the way they will, according to their language, the way they will all understand, you are rigid, and you are telling them that today we are going to dance. We are going to use dance to explain sanitation or cleanliness. But there is somebody in your class that cannot dance, or somebody in your class that doesn't even have legs. But you have prepared your lesson using dance as your teaching strategy. You have to pivot. You have to use teaching method that will suit at least 95%, in fact, 99% of the people in your classroom. And then the next letter is clarity. You have to convey the lesson objectives the way I did when we started. Tell them, this is what is expected of you. This is what we are going to be covering in this class, in this course, in this unit, whichever one. And then the last one is H. You have to show empathy. You have to build positive relationships with students. From that, acronym TEACH, we came down and brought out some characteristics of good science teaching. Remember that the first one we said effective teaching. And effective teaching means that you are intentional about it. You are systematic about it. Knowledge must be transmitted. That is intentional. That is effective teaching. And from that, we came down and talked about characteristics of good science teaching, which is the same thing as TEACH. But now we brought it down and we are now mentioning, it should impart knowledge, the material must be interesting, students must be engaged, material must be explained clearly. It's the same thing that we've been talking about. And then we talked about the objectives of science. I gave you the 8 of them. Why do we teach science? Why do we teach science? So there are 8 of them. So I want 8 of you to give me 1 each. Oh, it's on the screen. I'm taking it away. Objectives of teaching science. Why do we teach science? Let's hear those that have been following.
Okay, ma'am.
You can raise your hand. Yes. Go ahead.
So, to encourage and
Okay.
enable
Lucia
students.
said, yeah. To encourage and enable students do what?
To develop inquiries, mind, and curiosity about science and nature.
All right, that's good. Okay. Lucia said to encourage and develop curiosity. That is good.
My is blessing.
That is
Not
good.
Lucia.
Yes. Oh, somebody wrote it on the chat. Ejim Lucia.
Okay,
And
is
blessing.
Igba
Both of you said the
blessing.
same thing.
Okay, ma'am.
Ah, okay. Eba blessing. All right. Collins said something earlier. It helps us to have more understanding about science and be able to understand science from the basics. Yes. Okay, I think that was what Collins was trying to say about the overall, aim of the integrated science. That is good. Yes. Someone's hand was up. Is it Jennifer? I'm looking for your hand. Yeah, Jennifer, go ahead.
It helps us to understand the nature of science and to understand that science technology work connected with.
Yes. The interdependence of science, technology, and society. These are 8 reasons that I gave you, objectives why we teach science, objectives of science, reasons why we teach science. And then I gave you the overall aim of integrated science. Why do we have integrated science curriculum? And I mentioned that it is to provide learning experiences that will enable students to develop scientific literacy. The reason we teach integrated science, provide the basics, just like Colin said, introduce the basics of science to students from a young age, preparing them for this, our society that is changing every which way, preparing them for further studies, preparing them for careers in fields, in areas where knowledge of science will be useful. If you do not teach basic science, if you do not teach basic science and technology, if you do not teach primary science or whatever science they call it in the nursery, and all of a sudden you expect to see doctors or software developers or data analysts or chemistry teachers, or how? As how now? It will not work now. Okay, Jennifer, your hand is still up. You want to add something? Jenny. Oh yeah, bring down your hand.
All right.
Okay. Okay, now we should be looking at, the nature of science. I want us to look at the nature of science. It's past 8 already. The nature of science and its implications for teaching. So I'm going to quickly run through this, and then I'll tell you what you are going to do for me in this unit. Now, when we talk about nature of science, it's just, we're trying to talk about the fundamental, the characteristics, the principles that define science, that define the scientific, enterprise. What do we mean? We're trying to say that when we understand the nature of science, both students and, educators, we know how science operates, how knowledge is generated. Nature of science is just how science operates. What is it like? Is science just one word that appeared from nowhere? No. How is knowledge generated? How does scientific thinking evolve? How do people just wake up and develop one law or theory? We want to look at the nature of science. So when we say nature of something, we want to know the makeup of that thing, how that thing they behave. That is the nature of that woman. What does it mean? If the woman is a bad person, That's the nature of that woman. That woman will come out and start fighting on the streets. That's the nature of that woman. It means that that woman is known for fighting. There is, in fact, anywhere there is fight, that woman will be there. So nature of science, what does it mean? We are trying to say that it is how science operates. It is how knowledge is generated. It is how scientific thinking evolves. There are implications of the nature of science, NOS, for teaching. If you know how science works, it will help you to, shape how you teach, shape how you explain things to both students and adults. If you know the nature of somebody, you will know how to follow the person. If you know the nature of science, you will know how to follow science. You will know what science is all about, how it happens. It is not juju. It doesn't just wake up and become science. There are processes. There are things that you will see and you say, that thing is science. So, number one, empirical nature. Science is empirical. Science is empirical. Empirical means that we need evidence. Science needs evidence. Science brings evidence. So if that thing does not have evidence, it is not science. How does the empirical nature of science concern you as a teacher? When you are teaching science, you must engage students in doing things, in practicals, in observations, in data collection. Teach them that is not everything they hear that is true. In fact, it's not everything you see that is actually true. You can go into a chemistry lab and test for something using litmus paper, and it will turn one thing to another color. That is nature of science. That is the evidence that you need. You can test for fat and oil in biology. You test for carbohydrates. You test for protein. Why are you testing for these things? You need the evidence. The other time we were saying that beans is protein. Beans is protein. All of a sudden, they're now telling us that beans is more carbohydrate than protein. There is evidence of that. It is people, scientists, that actually tested it. So science is empirical in nature. That is one of the nature, one of the things that you will see and say, yes, that thing is science. Empirical in nature means that evidence is involved. This one is not you go explain tire, no evidence. It's not science, so it's not science at all. You will explain tire, but evidence go there. That is science. How does it concern you as a teacher? That is implication for teaching. You must teach your students to test everything. Don't just swallow anything you hear, hook, line, and sinker. Be curious, ask questions, keep notes, take recordings. They are talking, write it down. I put A and B and it gave me AB. Write it down. That is your evidence. It is empirical in nature. So science is empirical in nature. Science is subjective and objective. It is subjective and objective. What does that mean? Science can tell you that this thing is this today. It has subjected you into believing that one. But see, tomorrow, another evidence will come out. And what will happen? It will change. But evidence will be involved. How does this apply to you as a teacher, as an educator? You have to emphasize the importance of impartiality. The importance of impartiality. You must keep pursuing objectivity. Let it be clear. Today, A plus B is equal to AB. We agree. There is evidence. So, but they must also understand that tomorrow it can change. So you should always discuss with your students the distinction between subjective beliefs and objective evidence in science. Distinction between subjective belief and objective evidence in science. Like I mentioned earlier, eclipse of the sun. They will tell you that one wizard is coming to marry. That is why the eclipse of the sun happened. That's a subjective belief. But there is an objective evidence in science. I don't know why Collins is laughing. Because but that is true. So you should be able to clear such misconceptions. The next one is tentativeness and change. Science changes. I've mentioned that earlier. It is dynamic. It is subject to revision. Science changes. It is dynamic. It is subject to revision. What you know today, tomorrow, in fact, it's like updated version. Today it is Samsung A36. Tomorrow it is A50. It is iPhone 10. Tomorrow is iPhone 10X. It's science that they are doing with our money, but it's science. It is subjective. It is dynamic. It keeps revising itself. If you are a data analyst, if you are a web developer, you will know that every day, almost every day, you will just wake up one day, open your laptop, and you are seeing bugs everywhere on your web. You will keep debugging and debugging and debugging. That is why your apps in your phone keeps updating. Today, WhatsApp will update. Next week, it will ask you to update. They are debugging things. They are bringing in new things. That is what science is all about. That's what science is all about. So, as a science teacher, how does the dynamic nature of science affect you? What is the implication of that in your class? You have to teach students that scientific knowledge is tentative and may evolve with new evidence. I was discussing something with somebody, about surrogacy, IVF, and all that, and I said, 10 years ago, I am like 70% sure that 10 years ago we didn't know what surrogacy was all about in Nigeria. I'm not sure we knew anyone that would come out and say, I want to be a surrogate mother, or I want somebody that will help me and carry my baby. In fact, if you mentioned it then, they might stone you. You like as if you are, you have small scoy. But now it has changed. People are now talking about IVF. People are talking about, other alternative ways of having biological kids. Things change. So in your classroom, you must mention it. Things change, usually for the better. All right. And the next one is creativity. It is another nature of science. Science is creative. Science is imaginative. It is creative. It is imaginative. Science you can sit down like this and begin to think, I don't have strength to get up from this chair and get my remote from that table. And then you start thinking how to build a robot or how to build a remote that can respond to commands. The next thing, you will just see it all over. They now have remotes that you can call. The same way we remember when Alexa, do this, Siri, do this. If you go home and tell your grandmother that you can tell your radio, Alexa, play this, and the radio comes on or the light goes off, your grandmother will be like, what are you people eating in that township? Something is wrong with you people. But it is happening. It is somebody's creativity that brought Alexa. It is somebody's imagination that brought Alexa, that brought all these chatbots that we are using now. All these generative AI tools that we are all enjoying now. It is somebody's imagination. So science is creative. It is imaginative in nature. How does it apply to you as a teacher? You must highlight creativity in your classroom. Encourage it. Allow people to, come up with solutions to problems. That is what you need to do. There are so many points here. Another one is scientific community and collaboration. Science is all about community. Science is all about collaboration. That is why in your classroom, try and be doing group work, project work, do it together. Science is all about collaboration. That is, if you go on Google Scholar, in fact, on Google and type something and you see somebody's article, you can see Eze Ezea, Igwe, this one, 2026. Ezea is in science education. Eze is in data analytics. This one is in English language. All of them will come together and write a paper. Interdisciplinary. Science is all about collaboration. So in your classroom, try to encourage collaboration, teamwork. Yeah. Okay, so we also have societal, you know, of course, we talked about science, tech, and society. So you should know that. So there are others here that I will send to you later. I just mentioned a few so that we can go. I want us to leave by 8:30. Now, like I said, there is this portion of this unit that I love so much. It is the current trends in integrated science education. But I'm not going to dive, start talking about it. There are trends. In fact, I think integrated science is the most, how do I put this? It's a course that has changed so many times that people, if you're not careful, you get confused. Integrated science has moved from general science to primary science to integrated science to basic science and technology, and now we call it intermediate science. These are trends. So I don't want to start telling you this is what it is, this is what you are going to do for me now. You are going to look up trends in integrated science teaching. I have it here, but I don't want to start telling you what it's all about. I want you to go and do that research. This is your area. This is what you are doing in this university. So you need to know the trends. So I want you to go and research and find out how science teaching started in Nigeria. When did it start? What happened? Why did we suddenly have what we call science? I want you to look at how the curriculum has been developed over time. I'm going to drop this for your course rep. So she's going to, send them to you so that you know what I want you to do. I just want to mention it so that we can all go. I want you to look at the trends in integrated science teaching. How was integrated science introduced into Nigeria educational curriculum? How? What happened? When did it start? What was it called? I have here, it began as primary science, general science, and so on and so forth. We used to have 6334 system of education. All of a sudden, they said it's 934. Now they are saying another thing. I want you to do that research. If you want, you can type it out, you can write it out, anyone you want, but I want you to submit it to me. I want to read what you have come up with. The trends in integrated science teaching. If you are in integrated science education, you should know how this subject started, what it has gone through, the changes that it has gone through, and then what it is right now. The good thing actually is that no matter the evolution, no matter how many times the name changes, the overall aim remains the same: to bring every person to the minimum basic, tiny, foundational scientific literacy. So whether it was called primary science or intermediate science or basic science and technology, what we are doing as integrated science educators is to bring science to everyone at the level where they are. That is what we are doing. So I am going to articulate this thing and send it to your course rep this night. So she will send it across to you. So I need you to do that research. You should know what it is you are studying and the trends of what it is you are doing inside this university. Put it down in writing. Please try as much as you can to not go and prompt ChatGPT to give you rubbish. I'm not saying that ChatGPT is stupid. I'm not saying you should not use artificial intelligence. I am saying that you should also use your human intelligence. Some of you will just carry that question, drop it there, and it will give you something and you give it to me. I will pick the first person's own, pick the second person's own, and you people did the same prompting. I will pack it and send it back to you. Whether you are using Google Scholar or you're using any AI tool, it's not a problem. The problem is not applying your own human oversight. That is what it is called, human oversight. And the best way to catch you is if I put this as a question in your exam. Many of you will fail it. Remember your last exam. The test I gave you, the assignment I gave you appeared in the exam script, and many of you didn't do well in it because you have used an AI tool to get your answer and forgot to read it. Do this research whichever way you want, but apply your human thinking. There is a reason why it is called artificial intelligence. Use your own natural intelligence plus the artificial intelligence to give you what you need. Okay, so before we go, do we have any questions? You can unmute yourself and ask. I'm going to stop sharing quickly. All right. Before we go, do we have any questions? We have 5 minutes to go. Let's see what we have in the chat. Yes. Thank you, Obiora. Yes, to communicate scientific ideas, arguments, and political experiences. It's not political, it's practical. Obiora, Ezinne Obiora, it is practical experiences, not political. I'm putting it in the chat. Practical experiences. I'm waiting for your questions. Practical experiences is in the chat. Yeah. Thank you for that submission. Okay, Odnaka, I think we don't have any questions. So I will send that stuff to you right away. And with that, I can, if you don't have any questions, I can comfortably say that we are done with Unit 1. We'll communicate to you on when we can look at Unit 7. Unit 7 is the place of laboratory in integrated science teaching. You will get a date and a time for that one. So, yes, so we are going to be calling it a day. Yeah, okay. Jennifer, you have a question? Can an integrated science teacher teach in, sorry, let me open the chat. All right. Can an integrated science teacher teach in senior secondary or only junior? That's a beautiful question, Jennifer. I am an integrated science teacher. I did integrated science education in BSc, master's degree in integrated science, PhD in integrated science. I'm teaching you, and you are not in senior secondary, nor are you in junior secondary. Does that answer your question? Jenny? Does it answer your question? Good. You can teach anywhere. You can teach at any level. And I know I've mentioned this before. I do not just teach you in, the University of Nigeria. I teach across universities all over the world. So no, it is not just in senior secondary. It is not just in junior secondary. But one will have to furthermore to teach university students. Yes. Well, I was still doing master's degree when I started teaching university students though. So if your intention is to teach, because you can actually not teach if you don't want to. There's a reason why it is an integrated science. You can have a niche. You can have this what's another word for niche? This small portion that you love. Let me give you an example. I know someone who studied integrated science BSc, And she came to me and said she didn't want to do education, neither did she want to do integrated science. She wanted to be in theater arts. Yes, she wanted to be a dancer. But because she was scared of her dad actually wanted her to be a nurse. But she got, integrated science education. And then she came to me and she was complaining. He was in the classroom. And then I asked her, so you know how to dance? You are very comfortable with dancing? She said, yes. I said, do you know that you can actually communicate with dance? I don't know if you know that, but there's something called music communication. You can communicate with dance. She said, yes, that she knows. She has done some, some small shows and all that. She's very comfortable with dance. It's her comfort zone. I said, okay, you have graduated and you did well. You have a very beautiful 2-1. Now you are going for your National Youth Service. Why don't you find a way to merge dance with integrated science? She said, how? I said, okay, let me not tell you how. Go home, open up any AI tool that you have. Ask that question. How can dance be used to communicate integrated science? What is the relationship between integrated science and dance? She did. And then she came back to me after 2 days or so and said, Ma, look at what I have. Oh, I can actually do this. I said, okay. She started creating content. I'm not even joking. She's on TikTok. Started creating content, started talking about this, about that. In fact, she started talking about her life history, how she did. She's a youth corps member now. And then one day I called her, I said, okay, now that you are doing this, this is beautiful. How about finding, some small courses that you can take on science communication? There's a skill. There is a course called science communication. You can do it for 1 month, for 3 weeks, for 12 months, depends on what you have. There are companies that are looking for people that can help them reach people. This is a story for another day. But I need you to think outside the box. I teach in other universities, and I don't teach integrated science. In some schools, I teach ITS. In some schools, I teach communication. In some schools, I teach this. These are things that came out from my integrated science certificate. So if you don't want to be a classroom teacher, that is beautiful. It is not by force. But this one you are doing, make sure you do it well, so that if we need you here, we can come to you and say, come back to us. Come and teach our students, and then get your master's degree so that you can grow. You can still do so well that someone else will call you from wherever and say, please, I need you to introduce my children to so and so. And then you teach them from your house, the way I'm teaching you right now. So if you are very unsure about what you can do with this certificate, you can come to my office. We'll talk if you want us to talk. I think we can take it. Let's leave it at that because it's past 8:30. So if you need me, to talk to you about something, you can send me a message and we'll book some kind of time so that we can talk, and let's see how we can, help you align your interests. Okay. All right. Thank you. Any more questions? Okay. So I think I am recording this session. I don't know if it worked, but oh yes, I am. So I am going to probably upload it and send you a link so that you can go back and watch the recording. And then those that didn't come to class might actually go back and watch it. I'll think about it, and if I feel comfortable with that, I will upload it and then send the link to your course rep. So without much questions anymore, I think it's okay for us to say good night. And it was lovely having all of you here with me. Thank you, Loveth. Thank you, Collins. Thank you, Lucia. Thank you, Danielle. Thank you, Judith, Promise, Chelsea, Kamsi, Odinaka, Favor, and Purity, and the other ones that left. Thank you all, and see you when I see you. Good night.